Yeah, today is the last lecture in our course. So, yeah, after this lecture, you will receive the last homework, and also today is the last day for the second homework. I'll check it on weekends, and we'll share the result about the homework in general chat. Okay, so today we'll talk about deploying your application, and before that, let me share the agenda. I have this slide with me. Something about the lecture and the agenda for today's lecture. First of all, of course, I'll answer your questions related to your homework or like previous lectures. Then we talk about client server just a bit because we already talked about that in previous lectures. About application development workflow, what is DNS and CI/CD, like processes, what are them, how it help us, and so on. And the last thing in our agenda in our lecture is Docker, a very interesting and good application. The application. Okay, cool. And let's start from Q&A. If you have any questions, you can share them into chat. You can raise your hand or ask them and ask them by voice. Does this homework get a manual checking tool? Yes, we have a bot that will check your homeworks automatically, but this bot is not perfect. And yeah, we've seen that for the first homework, it didn't work great. And I've tested it for some homework. I've chosen some homework from your from you, and I tested this homework several times with the same bot, with the same code, but the result was different. So after first round, it was like 40 score. The second one was 60 and so on. So it doesn't work really good. That's why I don't think it's needed to use this bot. Yeah, I'll do it manually. We'll share the result with you. And I've asked you to make a pull request instead of merging everything into the main branch, because if I see the pull request, I'll be able to leave the comments and highlight some moments that are not very good, that you can improve, and give some suggestions. I think it will be helpful for you. Yeah, so please you make pull requests instead of pushing everything to develop. I'm sorry, merge request in GitLab. The name of these things is merge request. Okay, the deadline for homework 2 is today, right? I forgot to put EST. Yeah, it's today, but today is included, so we can finish this like at the end of the day. Yeah, and so about the third homework, the deadline won't be next Thursday. It will be a little bit later, because the third homework is the hardest one. That's why 1 week can be not enough. That's why I'll prolong the deadline, and I think I'll give about 10 days to finishing your homeworks. Okay, cool. I don't see any questions in the chat. I think we can start. Give me a sec. Okay, yeah, let's talk about deploying. And before that, let's discuss, let's talk about our modern web kind of architecture. Yeah. By default, most of applications use client-server architecture. It means that there are two parts. It's a client. It's in most cases it's you. Yeah, it can be your smartphone which you're using for accessing some website, or can be laptop, computer, even some. It can be also some, I don't know, terminals in some, for example, airport, or even your watches, or I don't know, anything like smart bulb also can be a client. It depends on the on your like server capabilities, but yeah, your also can be the client. And the server is the thing that you can like write, and this server should be placed somewhere. Yeah. And since we have a lot of users, we can have a lot of users, a lot of clients, all of them should be connected to the same server. Since that, we need to have kind of ability to share our like server to them, to make our server accessible by our clients. Yeah, also on the server part, we store our data, we deploy our database, all of that is server. A couple note about like modern big applications. In most cases, there are not just one server. There are a lot of services, there are a lot of big architecture in the background. It's not just the one like simple Node.js application. Because if we're talking about such big companies, let's say just Google, yeah, it's not enough to have one server on the backend. There are a lot of different services. There are a lot of services that you even don't know about, yeah, because Google needs to be run on every like continent, on every place in the world. That's why the servers should be located in many locations instead of like having only one location. So that's why for big application, there are not just one server, but a lot of them. But we are talking about small ones, and in that case, you'll need to have only one server. Okay, let's go to the next slide. Here, the slides that I already shown to you in the previous lectures. You can see the process, how applications, how they are deploying. First of all, we gather information about the like desired application. For example, some customer comes to you and says like, okay, I want an online shop, please do it to me. So you need to gather the information, what this person is going to sell, who are their customers, yeah, where these customers are located, how many users should be on this, how many visitors he's expecting, and so on. So we need to gather a lot of information. We need to make a lot of analysis to understand what technologies do we need to use, how many developers do we need, and so on. After finishing this stage, we can go to the next one. We can design, and yeah, as already said before, it's not only about the designing like front end interfaces. Yeah, it's not only about the like drawing buttons and text on the and drawing how it would look like for users. It's also can be technical design. Again, you can design your architecture and so on and so on. So it's not only about something that client only sees. It can be everything. So in that part, we just um, thinking about how should be it implemented and so on. The third part is implementation, is just coding. The most interesting part, I think, at least for me, yeah, because you need just write the code, and in that part you can use like any technology. It can be Node.js if we're talking about backend. On this screen we have Angular, but it can be anything. It's just implementing the thing that we've already designed. So then we need to test that. Yeah, our QA engineers will be testing. Also, we need to write tests for our code. So here's the example of tools that can be used. Yeah, just Mocha, all of that libraries are using for Node.js to write tests. The next phase is development, and that the phase that we are going to discuss today. So talking about deployment, what does it mean? So for example, let's say your first homework, yeah? Let's imagine that your goal is to create a site that can be used for storing files, yeah? And on the first phase, we will think, okay, we need a site. Let's discuss how many endpoints do we need to have, how many files can be stored, and so on and so on. On the second part, we'll design it. We create a Swagger file. We create the, I don't know, some, we mark some points like, okay, the first point, it should be accessible by such endpoint. The second point, it should be accessible without authorization, and so on and so on. On the third part, we implement that. And this part you've done on your first homework. After that, this part should be tested, and it's kind of what I've done when I were reviewing your code. Yeah, I'm not like testing that, but I'm like reviewing that. And the next part is about deployment this code, and this is what we need to done to use our application in the like users, yeah, because currently if you run your server, this server will be accessible only on your local machine, and if you run your application locally, the guy from, I don't know, another location, or even from the second that sits near to you, he cannot access your website because it's not deployed anywhere. It's running only on your local machine. And deployment is a process when we can like put our application to some server, and this server will serve our application, and anyone from any location can access our server. And like the process from moving this our code to the server, the name of this process is deployment. I'm sorry, yeah, deployment, the right word. Okay, so here are the example of what tools can be used for such process. The first one is Jenkins, is a CI/CD tool that can be used for CI/CD. So when you want to deploy something, you can do it manually. How can you do it? So first of all, you need to buy the server. Yeah. I'm not really buy, you need to rent it. Yeah. After that, you need to put your code somehow on the server. To do that, you need to, there are several ways, but you can, for example, install Git on your server and put your changes to GitHub, then pull your changes from your server to the server. After that, your changes are on the server. You need to run them. Then you need to install a lot of things like NodeJS should be installed. Maybe NPM should be installed because you need to install your dependencies. Also, if you're using some extra things, also they should be installed as well. Okay, everything is installed. You can run this server. You run your application and everything is running. And now, if the configuration of network is correct, you will be able to access your server by some IP. You can like use IP of your server and provide the port number, and you will be able to access this server. The second, and Jenkins, yeah, the process I described, it's how you can do it manually, but yeah, it's pretty interesting, yeah, to be honest. But when you do it once, that's fine. Okay, the second one will be okay. But starting from the third, fourth, and so on, it will be really boring because you need to do a lot of the same stuff. It will be routine, and you need to automate that. And Jenkins is the tool that can help us to do it. So you need to just write scripts, yeah, once to provide the information how the application should be deployed. What code should be from what branch, what tools should be used, what like application should be installed on the server, and you do it only once. And after that, for example, in my project, when I want to deploy something to production, I just click one button. For example, we finished implementing our features. Our test engineer said like, okay, everything is working, we can deploy it, and then I click one button. I don't need to care about like going to one server, provide the pull the code from GitHub and so on and so on. I'm not thinking about that because there is a tool that will do it for me. The second one is Docker. We'll discuss like in deep about Docker a little bit later. I'll try to explain you why Docker is important and how to use it. And the last one is Kubernetes. We won't discuss about that in this lecture, but Kubernetes is a really good thing. When you have a big application, you have a lot of different services, and Kubernetes is the way how to orchestrate them. So he can think about like we have, for example, Kubernetes can see that there are a lot of requests and the server is not okay, and he will restart the server or he will add one more server and so on and so on. Yeah. Okay. And the last part is maintenance. Yeah, when you finish, when everything is deployed, you cannot write perfect code, yeah, because always when you're writing the code, there are a lot of bugs. Not a lot of them, yeah, but there are them, even if they are not shown yet, yeah, because I've heard some interesting thing that for every 1,000 rows of code, there are a couple of bugs, and that's like the thing that you cannot prevent. So of course, it's just a statistic and so on, but when you have a big application, yeah, there can be a lot of issues that can occur during the like working of this application. That's why you need to maintain this application, and that's what's talking about on the fix phase. Okay, before we talk about CI/CD, we need to understand how you can access the server, why you cannot use your laptop for running your application, and so on. We need to, I need to explain you what is DNS for that. Yep, DNS is the protocol, the main network servers. So actually, I'm not sure about the like this what this letter stands for, but this protocol helps us to have names of our websites. So when you try to access some website, the network doesn't, the internet, yeah, it doesn't understand what is mean Amazon.com. It doesn't understand it. So you need to provide the address that you're going to access. And the address, when I say address, I mean IP address is like, I don't know, 54.128 and so on and so on. It's like 4 numbers, and they separated by dot. And here the example of these address. So but so as already said, these names, the internet doesn't know what does it mean. And if you want to access the site, you need to provide the address. But when we have let's imagine the situation that we don't have these domains. Yeah, I'm talking about Amazon. Yeah, like let's say we use only IP addresses. In that case, you won't be able to remember everything. For example, you would like to Google something, but you need to remember the Google IP. You need to, okay, the Google IP is maybe 54, then 12, then okay, but it's like 4 numbers. You need to remember 4 of them for one website. And if there are a lot of websites, of course, you will be need to remember all of them. And that's not really human readable. That's why DNS server was invented. So the idea of this DNS server is to have just a simple map. Yeah, we have an IP address and we have the domain name. So this like kind of table, yeah, of course, under the hood is like there are a lot of different and complex logic, but if talking, if to try to explain you, I'm trying to simplify it, and let's just assume that there are just table. We have IP address and we have a corresponding name. And for example, when you're trying to access Amazon, yeah, here the whole workflow. Let me use perfect drawer things here. So for example, you'd like to access you're this guy, yeah, and you'd like to access some server, and you'd like to go to Amazon. First of all, you put amazon.com in your website, or www.amazon.com on your browser. You click enter. After that, the request will be sent not just to Amazon. It won't be sent directly to Amazon. It will be sent to special DNS server. Yeah. So this server was invented special for having this table. I mean, this map, like, and when you say like, I want to get Amazon IP, yeah, this server will try to find in his table that does he have Amazon IP, and if it does, yeah, it will return the special IP to you. So this IP will be returned to your browser, and your browser get this IP, and now your browser will make the request to your IP, and this will be done after getting the IP. The request can be done directly to the server that Amazon is hosted on. And when the request is made, yeah, the HTTP request is made, so the response will be returned to you. So that's what is DNS. Yeah, and of course you can use IPs. Yeah, you don't need to use DNS names. It's possible. Maybe you've seen some I don't know, like websites when you can just provide the numbers instead of names. Yeah, but like these domains, they are easier to understand, to remember, to write, and so on. So that's why there are a lot of different domains, and they are like, some of them are really expensive. If you'd like to have the website, you need to buy domain. Yeah, I mean, you cannot buy Amazon.com because it's already reserved by Amazon. Yeah, but if you'd like to buy something for your shop, you can, for example, go to some kind of, I don't know how to say it, like shops, DNS shops, and there you can check whether your domain is free and can be bought or not. And the price is not really high. Yeah, it's a couple of, let's say, maybe $10 per year, maybe a little bit more, but there are a couple of domains. I mean, a group of domains that are really expensive. For example, there are like domains.dev, if I'm not mistaken. They are expensive, and also there are .io. They are expensive as well. But if you're trying to buy a simpler domain, let's say, I don't know, my shop for selling some shoes.com, in that case, I don't think it will be really expensive. You just need to buy it. And what happens next? You buy this domain, and you'll be able to, for example, before, like, I've suggested you buying a server. Yeah, if you want to deploy your application, and you deploy your application to the server, you have the server and you have IP. So this IP can be used to access your server, but it's not really beautiful. That's why you need to have a domain. You buy the domain, and after buying the domain, you will be able to, like, connect them together. You will go to a website where you bought your domain, and you'll be able to create, like, kind of add a special row for this table to have this connection, like domain name and the IP. Okay, I want to, like, highlight the thing that I'm not asking you to buy something. It's just a way how you can do something. So you don't need it. You don't need to buy anything. It's just if you want to deploy your application to some website and so on. But also there are free ways to deploy your application. There are Netlify, there are Heroku. They can be used for free deployment. Of course, there are some restrictions. For example, you cannot use any domain you want. Yep, it should be here. The ending of your domain will be always heroku.app or something like that. But again, if you want to deploy something to show your friends or to have it accessible, you can use some free services. Okay, I can. If I go to the next slide, will it be? It will be cleared. Oh, cool. So this drawing, they are connected to the slide. That's great. Okay, let's continue. Let's talk about CI/CD. And I've already said it. I've already a little bit explained how Jenkins works. Talking about CI/CD, we have CI and CD. Also, there is one more thing against CD. CI stands for continuous integration. CD stands for continuous delivery, and one more, CD, is continuous deployment. But we won't talk about it now. So talking about CI/CD, what is CI? Continuous integration is the process when you want to make your like development continuous. What does it mean? For example, you run your code, you write your code and you'd like to put this code to server, but this code can be with bugs, yeah. And you, I don't know, you wrote a lot of tests. Also, you have some linter checks. Also, you have something else, and continuous integration is the process when you, for example, create a pull request and or you push something to your branch. Yeah, this CI tool will run the process of checking, like whether all tests are passed, like whether I don't know, like there are no yes link rules problems and so on and so on. So this should be done automatically and you don't need to do it manually. So this what CI means. So it can be it's everything is configurable. Yeah, you can configure your CI to run the everything on pull request, on pushing to branch, on pushing to branch with special name, and so on and so on by manual clicking. The processes that will be run can be also different. It can be just a test running, or it can be creating a special branch and then deploying it to somewhere, and so on and so on. There are a lot of different things that you can do with CI, but the main goal is to improve your like performance, yeah, improve, make it continuous. Yeah, you don't need to think. You made the push and then you don't need to care about it because CI will do all necessary things automatically and you might receive a special notification like whether it's okay or not. But instead of making it by yourself, you can do next task and just waiting for notification. So that's how CI works. And CD is the process of releasing the thing. So CI is about development, but continuous delivery is when you, for example, it's automatical deployment process. When you, for example, finish your work and you'd like to make a release, you just click the button. For example, as I described before, yeah, I can just click the button to deploy our application to production in my current project. So that's CI. I'm sorry, that's CD, continuous delivery. So that's how things work. Yeah, and here are the example of things that can be done on every stage, like code, build, test. It's all about continuous integration. Release, deploy, operate. It's about continuous delivery. Okay, and the last thing that we'll discuss today is Docker. Docker is very popular things if if we're talking about backend development. Yeah, in most projects. Okay, let me explain what is Docker. Docker is a tool that can be used for creating Docker containers. So Docker container can have like additional operation system inside. Okay, let me just explain the problem that Docker solves. For example, if you'd like to deploy your application on your server, what you need to do? As already said, you need to put your code somehow, deliver your code somehow to your server, but after that, you need to run your code. Yeah. And to do it, you need to install some dependencies. First of all, you need to install Node. Of course, it should be installed. Then NPM. Good. It should be installed as well. Then you need to install some dependencies of NPM on your project. Then you might be need to install something else that related to your that needed in your Node.js application. I don't know. It can be anything. It can be Nginx or anything you want. After that, you installed everything, and everything is good. Yeah, it's working. You run your application, everything is working. But after that, you need to install, you need to update, you need to run this another version of your application. And to do so, you need to update your Node.js. You need to update your NPM, a lot of dependencies. You need to think about that. And also, two versions of your application cannot be run on the same machine, and so on. And after deployment, that thing you need to for example, you'd like to stop your application. You need to know what you installed to remove that, because, for example, you installed your application, then you need to update, deploy a new version. You need to clear all stuff Yeah, because some dependencies cannot be used anymore. But if you do not remove them, they'll be on your disk, and in some time, this disk will be yeah, it will be full, and you'll get the error. So what does Docker do? If you're talking about like such deployment, you don't need to install everything on your machine directly. Yeah, you can create a Docker container, and inside this Docker container can be additional operation system. For example, most of the servers are using Linux, and Docker like fully integrated with Linux, because there are cool things in Linux core that helps Docker has access almost directly to your hardware. So it means that inside Docker container, the operation system that will be run there, it won't be any performance degradation because it has almost direct access to your operation system. It's not about virtual machines, it's different things. Because in virtual machine, the virtual machine is run on your operation system, but Docker runs almost directly to your core under the hood, of course. And you can create a Docker container, and inside Docker container, you can use, for example, some Linux, let's say Ubuntu. Inside this Ubuntu, you can create, you can install a node version you want, npm version you want, and dependencies you want, build your application, do everything you want. And after that, you decided to improve, update new version. You just killed one Docker container, create another one. That's how it works. And so Docker helps you to manage deployment process, and there are a lot of benefits. For example, you can build your container locally and then run this container on the server, or for example, you can get the container from server and run it locally, and so on and so on and so on. So there are a lot of benefits if we're talking about deployment process by using Docker. And also there can be several Docker containers that running at the same time, and several versions of your application can be run at the same time, and so on and so on. So I hope I explained you the benefits of Docker. And here just the architecture of how Docker works. Uh, First of all, we need to, let me see. Yeah. If we're talking about Docker, there is a Docker daemon, and there's the daemon. I don't know how to name it correctly. And this thing is just a daemon application, daemon process. Yeah, that's running on background, and this process is it cares about containers, Docker containers in images. Yeah. Before continue, let me explain you a difference between images and containers. So, Docker image is the kind of snapshot of the operation system of the disk. Let's say you'd like to use, again, you run your application, Node.js application. You will create a Docker image, and inside this image you'll provide a special thing. For example, inside this image you'll provide the special tools that should be installed. Yeah, npm, Node.js, dependency should be installed, and so on. And after completing these steps, image will be created. And inside this image, all file system will be like inside. Yeah, and you won't be needed to install Node.js again. Yeah, because it's already installed and it's packaged inside this image. And this image is just a snapshot, but from one image you can create a lot of containers, and you put this image on your machine, I mean server, yeah, and you create from this image a special container, and this container will have the same file system, but it will be copied, yeah, because image won't be mutated, it won't be changed. Yeah, you create a container, and container has everything that this image had. Yeah, and inside the container will be run your application, and you can create several containers, and they will be independent, but the base, like the applications by default, will be the same. Of course, you can install additional things on Docker image and so on and so on, but it's better to do it in images, because if you need to install in every container something, it's better to install it once in image, and then you won't be need to do it in container. And this daemon, it cares about images and containers. Just I don't know, kill them if you want to do it, and so on. And to kind of talk, yeah, to communicate with these daemon, yeah, there are several ways. Is terminal part where you can just run your commands to terminal, like Docker run. It will create additional container from some image. Or there are also some UI tools, for example, on Windows and on macOS. There are tools for running your for communicating, yeah, with the daemon by just clicking things without knowing about some commands and so on. And here we see like we have a registry part, and this part is something in cloud. When you create your image, you'd like to put this image to your server, and to do so you can use Docker Hub. And Docker Hub is kind of repository similar to GitHub, but instead of storing code, it stores images. And you create your image, push this image to Docker Hub, and Docker Hub can be used to on your machine. You can use Docker Hub and pull image from Docker Hub to your machine and to server. Yeah. When I say machine, I mean server. And you can create a container from this image on your server. That's how registry can be used. You don't need to think about, oh, how can I like transfer data from my local PC to the machine to the server? You can use just kind of can just Docker Hub. There are several alternatives of Docker Hub, but Docker Hub is the most popular one, which will store your images. Okay, that's how Docker works. Yeah, unfortunately, I just installed the Docker yet before this session. Uh, I'm not sure I will be able to do some demo, but we can try to use Docker for try to explain you how Docker works and so on. But before you can ask your questions, so yeah, if you have any questions, you can put them in chat or ask by voice. Could you provide some useful links for further understanding? Talking about Docker, I can provide the Docker. I'm sorry, I have some second. Yeah, okay, talking about Docker, I can provide just the link to Docker documentation. I don't have something special. You can find, okay, it looks like Docker has some guides. Yeah, you can use them. It's about Docker. Actually, the Docker is the most important part here because deployment, that thing, like it's easy to understand it on high level, and yeah, I don't think it's needed to find something else about deployment. But anyway, I don't have any special links. The only thing I can recommend you is Docker documentation. Yeah, unfortunately, I haven't prepared any links. So anything, anyway, you can Google like CI/CD process. What does it mean, and so on. If something is not clear for you. But again, now we can answer ask the questions you have, and I'll be able to answer them. That's next homework required Docker. I'm not sure, to be honest. I don't remember the details about third homework. I can check it now, and give me just a couple of seconds or minutes. I'll find the I'll find the homework details. Okay, talking about homework. And I have some issue. 1 second. Okay. Nope, the Docker, I don't see any Docker in your homework. Yeah, but anyway, you will be needed to deploy your application, and it's better to, yeah, you can use Heroku, you can use Netlify. There are free plans, and you can do it for free. Yeah, but Docker is not necessary for next homework. Okay, I can try to make a small demo about Docker. I'll try to show you how it works. Give me a sec, I'll prepare. Could you do some deploy demo first? Unfortunately, I cannot do deploy demo first because it will take like time because I don't have anything to deploy. I don't have like account in Heroku, Netlify. I can deploy something in AWS because I have account, but I don't think it's like I don't think it will be helpful for you. So actually, if you're talking about Heroku, there are a lot of guides even from Heroku team. So you'll be able to find them, and there are like step by step that you can do to deploy your application. And there are also deploying processes for Node.js. I mean, they have special scripts for Node.js. So unfortunately, I won't be able to do like deploy demo. I'll just give you example of how Node.js, I'm sorry, Docker works. Okay. Do you see the screen? Cool. Yeah, talking about Docker, I've already installed the Docker on my machine. And to use Docker, there is a command which with name Docker. Yeah, you can use Docker to do some stuff. Here's just example like helps, just manual how to use it. Yeah, there are a lot of different commands, and to check what containers currently running, you can use Docker PS. You can see that I don't have any containers. Yeah, there is no stuff. And I would, for example, I'd like to have installed Redis. Yeah, it's just a database that can be used for something in your Node.js application or even not Node.js. And to do so I would like to install, I'd like to create image, Docker image with Redis inside. And what should I do? First of all, I need to, I need to create a Docker file and so on. But actually, there are already prepared Docker images for some popular stuff. For example, if you're talking about Redis, I will like do some Docker Redis image. Yeah. Then we go to Docker Hub, as you can see here, and then we'll see the image name. And we need to just use command docker pull and then put the image name. We do this thing, and after that, Docker image will be installed. Here just several layers. Yeah, we won't go into details what layers mean in Node.js in Docker, But after installing this Docker image, I don't still have Redis, yeah, because I have only like snapshot of Redis. It's not running. There is no runtime. It's just like template, yeah. Cool. The Redis already the Redis image is on my machine. I can check it by image PS, not image PS. I can check it by images PS. Okay, just images. Look, I've put special command docker images, and here we have Redis tag latest. We can also use special tags, like we can install a special version we want. Image ID was created automatically. It's just a tag time when this image was created, and the size of this image. After that, I would like to create a container. So what do I need to do? I need to use docker run. Yeah. After Docker run, I need to provide the image. The image name or image ID that should be used for the new container. And let's provide the image ID. After that, I can just click run, enter. I'm sorry. And you can see that we can see some logs for Docker from Docker container. If I go to the new window, let me clear everything and put docker ps. We can see that I have Redis here. Here the container ID, here the image. Yeah, and you can see that the image and container, the image here like 64, and here the same 64 is the one that I've installed before. Command is the entry point, like the command that will be run after creating a Docker container, when it was created, the status of the container, and so on. So now I have Redis Docker. And what does it mean? I can connect to Redis. So I have application names Red. This application can be used to connect to some databases. Yeah. So we can let me put it here and here. We can read the documentation about Redis image, yeah, and check what port will be used by default, and so on and so on. But we can see that, one second. Okay, let's find port here. Okay, by default, Redis exposes like to use Redis. Yeah, you need to connect to port 6378 is default port, and you'd like to connect to some to your local machine. Of course, you need to use localhost, but most likely I won't be able to connect. Yeah, connection failed. That's because Docker container is this container is isolated. I cannot access this container. Yeah. If I try to access this container, I'll get the error. Yeah, because by default, Docker did not provide ability to access this container. I can go inside this container by running command docker exec -it. Then the name of the container is the ID or the name. The name of the container is busy edition. Yeah, it was added automatically, created by Docker, but I've provided the ID here. And the name of the command that we would like to run, it's bash. Bash, it's like just the terminal. I run this command, and now I am inside Redis. I'm inside Redis container. So it's not my machine. So we can check what files we have here. Yeah, we can go to root directory and check what files we have here. And you can see that according to the name of the files, it means that it is it's Linux system. Yeah, it's not Windows, because we don't have like disk C and so on. It's not Mac. Yeah, it's Linux. Yeah, and that's because I'm inside Docker container. And yeah, what can I do now? I can do some stuff inside this container, but I'm not going to do so. I'm going to stop my container. To do so, I need to just run Ctrl+C here. And now, and now I will kill my container. I'm sorry, not kill, I'll remove my container because I'm not going to use it anymore. I'll create additional one. To kill the container, I need to know his name. I need to run command ps -a because by default ps shows us only containers that are in progress, so that are not stopped. But I've stopped this container by passing a special signal by pressing Ctrl C. And now I have container ID. I will remove this container. The container is removed. Cool. And after that, I'd like to create a new container. But now I will provide a special arguments. So by creating such container, I need to provide some special arguments. So first of all, I need to provide flag D. So this flag will be used uh, to run this in background. Yeah. When I run this command, we saw that there are a lot of logs. Yeah, and they like I still don't. Okay, I see logs. Yeah, and if I close this terminal tab, the container will be stopped. And to tell to the Redis, oh, I'm sorry, to tell to Docker to run this container in background, I need to provide a special flag, yeah, just -d. Then I can name the container, and I'll just name it Redis. Oh, I'm sorry, no, Redis is the name of the image. To name the container, I need to provide a special argument, and then Redis container. Then flag D for putting it into background. Then we can use either name of the image, or image ID, and I'll use, for example, in that case, name. Okay, now to have access to the Redis, we need to expose a special port. And to do so, there is also a special argument for that. It's -p, if I'm not mistaken. Please, Siri, just okay. Okay, what's next? We need to find the way how to provide port. I believe it uses port by default. Okay, I just will do. We'll use default port. So by providing port, we need to provide actually two ports. First one is the port that will be on your machine, and the second one is the port from Docker. And for example, you can make a connection. For example, the 3000 port on the Docker container will be connected to, I don't know, 4000 port on your machine. And for example, if you have your applications, yeah, and you'd like to run them on your local machine in 3 different containers, but your application by default uses 3000 port, yeah, to access your application, it will be needed to run localhost 3000. And to avoid such collision, you'll be able to just to change ports for Docker containers. And for example, the first Docker container, the 3000 in Docker container port will be equal to 3000 in local machine. Then the second container will 3000 on Docker container will be equal to 3001 in your local machine, and so on and so on. And here you have provided the same like port in local machine and in Docker container. I press enter. Nope, but I need to. I believe the name of the image should be the last thing in the command, and press enter. I see the error. Fatal, blah, blah, blah. Reading the configuration file. Name Redis container. That directive of wrong number of arguments. Okay, it looks like I made some mistakes. Docker. Okay. Yeah, that's the mistake. I've provided Docker run, then the image name, image ID, and that's why Docker didn't understand what I wanted to do. So again, without name, and here the container ID. Now we can use Docker PS to check, and here we have like a container, the same thing, and we have a special thing that these ports, they are like mapped. Yeah, the port exposed, the port in Docker exposed to the port in my local machine. So I can do the same thing with Docker. I can go inside this Docker. I can restart the container and so on and so on. But now I'd like to connect to this Docker. And now I use localhost, and now I use this port. And this port, when I connect to my local machine, I have a mapping, and this port will be used in the Docker. And now when I click test connection, okay, it still failed. I wasn't ready for that. Okay, I need to provide some configurations. Okay, it wasn't, it's not such easy as I thought. Okay, just go the way like all developers do. Google it. So we do like Docker Redis run locally, and let's check what I missed. And when we go here, we just run ports, names, everything is okay. Install and run the container. I did the same. Blah blah blah. Okay, I'm not sure detail. I will fix it faster. I will fix it yeah, fast. So the thing that we can do now, we can go inside Redis. Okay. Redis container, the name of the container. Docker run exec. Docker exec. Yeah, I'm inside container. I can use Redis CLI. And now I'm inside Redis. So I can do some commands for Redis. For example, I can check what keys do we have. I can set, for example, I can add some value to database. For example, name will be equal to, I don't know, Ben. And now I can keys and find name. And now we have a special, like, we can result because the thing that I've added, and then can like get name and have the value of this name and so on. Yeah, unfortunately, I don't know how to connect from my local machine to like from my local machine to the Docker, because for some reason the connection is not the connection is failed for some reason, but the port is exposed. Yeah. Okay, so I'm not going to waste your time. Yeah, it looks something didn't work. Okay, just give me a couple of seconds. I'll try to do so. Okay, for some reason localhost doesn't work. So by default, I think I know the reason. Okay, it looks like the issue with my laptop. So by default, when you put localhost in your web browser or anywhere, it will be it's the same DNS name, but this DNS name will be resolved not on DNS server, it will be resolved on your local like DNS server. And by default, it's equal to 127.0.0 and .1. So it's like these two things are equal by default. Yeah, but looks like I have some special configuration. That's why it didn't work. That's why I need to use explicitly IP, and I can connect to the server. And now I connected. Yeah, and now we can see that we have a name here. It's Ben. Yeah, I can create something else here. I can create, let's say, let it be just string. Yeah, it can be some, I don't know, production, your users, and here again the same thing, Ben. And inside Ben we'll try to add some, I don't know, description. Who is Ben? Ben is a good developer. Okay, now I save this thing. How to save it? Save it here. Yeah, and now I can go to inside my container and do the same thing from CLI, and I can go like keys. No, not even keys. I can name. I can provide the whole name like it, and we can see that we got this information, and that's how it's working. Yeah, we can do the same stuff with Node.js application, and it will be run on your container. And now, for example, it's like on my local machine, and I don't need Redis anymore. I just do stop Redis container docker ps. We see that nothing is running. We use ps -a. We see that we have two containers. I provide docker rm, this one and this one. So I already remove. Okay, something is not good. Okay, now they are removed. Ps -a. Nope, one of the container is not removed. Docker rm. Cool. Now I don't have the containers. I can also delete images. Yeah, I can run rmi to remove images and provide name Redis. Now the image is deleted, and so that's it. I don't need to think what Redis, where Redis stores our information and so on and so on. I don't need to care about that, because if I need, I just remove that. And the same thing we can do on our servers, on our with our applications and so on. And now if I try to reconnect, yeah, I cannot do it because yeah, the container is removed, and I can just try to do it again, 0, 1, and then test connection. No, it doesn't work now because the container is removed. Okay, I hope you enjoyed this demo. Unfortunately, I didn't do it like from the first glance, but yeah, I hope you understand what is Docker, and it's really helpful. But yeah, you don't need to use it in your homework, but you can. So in future, in your development career, if you're going to be a Node.js developer or even any backend developer, like it most likely you will be needed to work with Docker. It's a big topic. There are a lot of things. There are a lot of things to know there. It's like not really simple, but it's very interesting. So in most cases, again, you as a developer won't be needed to work with Redis with the Docker a lot, because this thing is more connected to DevOps, the guy who's responsible for the deployment. But if you're good in Docker, it's a big plus, because backend developers should know how to deploy applications as well. Okay, that's it from my side. Let's go to your questions if there are some of them. If no, we can finish. So yeah, while you thinking about your questions, I will just make some recap. So this is our last lecture. I will share the information, the presentation from the lecture after this lecture, and also I'll share the details for the third homework. In some days, I'll share the information about your second homework. I think it will be done after weekends. And that's actually it. Yeah, in 10 days after today's will be your deadline for the third homework, and the same process. I will share the information about your results after some days after deadline. Yeah, that's it. Cool. Yeah, I don't see any questions. Please raise your hand if you are like writing something. If you have some questions, but you need some time to write it. Okay, I don't see any hands. That means that there are no questions. I think we can finish. Thank you guys very much. It was interesting for me to explain you something related to Node.js. Yeah, good luck in your career and have a good day and weekends. Yeah, they will be very soon. Goodbye.